Some of the earliest examples of teaching machines were based on following a set of rules. We can think of these expert systems as being given a sequence of specific instructions. If X happens, then do Y. These systems proved to be useful, especially in business applications, but trying to come up with a rule for every situation is really difficult. As more data and more computing power became available, a different approach started to emerge, which is more like flashcards. Flashcards are a type of labeled data. We show a child a picture of a dog, and then we tell them, this is a dog, or this is a cat. That is basically what we are doing with a machine, feeding it many examples of labeled data, so that over time it learns dog versus cat. This process of using labeled data to train a machine is called supervised learning, which, as the name suggests, involves active supervision. Yet what the machine actually learns isn't really knowing what a dog is. It's more like it learns that this particular set of data points represented in pixels equals something called a dog. Also, someone has to label all of that data, which means that we sometimes tell our machines things that contain bias. Maybe the person labeling our data really likes cats. Everything looks like a cat to them, so the training data is encoded with a cat bias. This might sound silly, but imagine if the stakes were much higher. Sticking with our flashcard example, suppose we give our machine cat and dog images, but no labels. We ask it to group the images for similarities. The machine might notice some patterns in the data that lead to clues, perhaps that cats in general tend to have pointy ears, or in machine terms, the pixels are formed in a certain pattern. It will use this learning to start to cluster the data into similar groups. This use of unlabeled data is called unsupervised learning, which, as the name suggests, happens without active supervision. This is a little more like learning in the real world, where things are not labeled, and this makes the task harder for the machine to do, and also means the results can be less accurate. Unlike a human learner, our machine just has the data it's been given and no other context for learning. A human is deciding what data the machine will receive. Finally, there is reinforcement learning, which is even closer to how humans learn. We explore our environment and then learn from the feedback that the environment delivers in the form of reward or punishment. Think about touching a hot stove. We get the message pretty quickly. Machines, too, can learn by exploring their environment and doing more of what gets positively rewarded. The reward in this case is typically defined by a human. Supervised, unsupervised, and reinforcement learning. These are simple but key examples that make up current machine learning techniques.